Now we're going to set up a proportion. This is section 5.4 applications of proportions, and let's just think about what a proportion is. A ratio on the left equals a ratio on the right. So this is what a proportion looks like, and we're going to set up a proportion here. Proportion is nothing but an equation that looks like this. So when we read a question, keep in mind that we have to think about two quantities that are being compared here. So keep that in mind as you read the question. What are the two quantities that we're comparing here? Suppose two adults produce 63.4 pounds of garbage in a week. How much garbage, so basically that's your X, will 50 adults produce in a week? So two adults produce 63.4 pounds of garbage. How much garbage will 50 adults produce? So this is the question. So what are the two quantities that are being compared? Number of adults, amount of garbage. Number of adults, amount of garbage. So make sure you have number of adults in the numerator. I mean, it doesn't matter which way you go, but make sure you're consistent on both sides. If number of adults is in the numerator on the left, make sure that the number of adults is in the numerator on the right side. If garbage, the amount of garbage is on the left in the denominator, then the amount of garbage on the right should also be in the denominator. So the two quantities are number of adults and the amount of garbage in pounds. So let's write this down. Two adults produce 63.4 pounds of garbage, and that is proportional to the amount of garbage that 50 adults will produce. And we don't know what it is, so our answer will be X. We're going to call it X for now, and we're going to figure out what X is. So I'm going to drop the units, so it's just the numbers that we work with, but at the end we'll think about what the answer means. So that's 50 over X. So we're familiar with these kind of equations. One method that always works is cross multiplication. If you can do some other method, that's fine. Just make sure you're following the rules of solving equations. So you have 2x equals 50 times 63.4. And now, just like before, we have to solve for x. So we're going to divide both sides by 2. And that's equal to 50 times 63.4 divided by 2. So we cancel common factors and we get x equals 50 times 63.4 divided by 2. So at this point we have solved the equation, and I'm going to write down the answer using a calculator. But remember, in this class we're only going to check the answers using a calculator in class or when doing homework, but we're going to do everything by hand. So that is, we're going to see if we get this answer. Remember, keep this in mind, 1,585 pounds of garbage. Let's see, unless I've entered something incorrectly in my calculator, this is what it should be. Now, in this case, there's 2 in the denominator, and if we could just get rid of that. So 2 times 25 is 50 times 63.4 divided by 2. We cancel the 2's. And if we multiply 25 and 63.4, so let's put 63.4 here and then multiply with 25. Just remember what multiplication involves. If it has decimal numbers, we just multiply pretending like the decimal point doesn't exist, but at the end, we're going to place the decimal point using the correct rules. 5 times 4 is 20. 5 times 3 is 15 plus 2, 17. 6 5s are 30 plus 1, 31. 4 times 2 is 8. 3 times 2 is 6. 6 times 2 is 12. So 0, 9 plus, I'm sorry, 7, that's a 7, not a 9, I think. 7 plus 8 is 15. 7 plus 7 is 14, so 7 plus 8 is 15. 6 plus 1 plus 1, I carried the 1 over here, so that is 8. And 3 plus 2 is 5, and 1. So what we have is 15850. However, at the end, we have to remember that this is a decimal number and count the total number of decimal places in both the numbers. There's 1 here and none here. So that would just mean a total of 1 decimal place. So it is 1585. That's our answer because it's 0.0. And remember what we were trying to figure out? It was the number of pounds of garbage that 50 people create. So when you think about it, if 2 people create 63.4 pounds of garbage, how many pounds of garbage will 50 people create? And it makes sense that it is a large number, which is close to 1,500 pounds. So if you get something that doesn't make sense, you have probably switched one of these ratios. So be careful. If you're careful right from the beginning, making sure that if you have the number of adults in the numerator, make sure you have the number of adults in the numerator on the right side. Make sure these two match as well. Amount of garbage on the left, amount of garbage on the right, both in the denominator. If you switch these, you're going to get a completely wrong answer. Now let's look at the next problem. Now Evelyn, and we're talking about Evelyn who ran for elections, won the election by a 6-to-5 ratio. Okay, so what does this mean? Evelyn won. So for every 5 that her opponent won the votes, she got 6 votes for every 5 votes that the opponent got. So 6-to-5. This is Evelyn and this is the opponent. If Evelyn received 7,230 votes, so that's Evelyn, how many votes did her opponent receive? So let's just call it X. So what are the two quantities that we're comparing? Always keep that in mind as you're reading the question. So here we are counting votes. And what are the two quantities we are comparing? We are comparing the votes that Evelyn got and then the votes that her opponent got. So Evelyn over opponent equals Evelyn over opponent. That's what your equation or proportion is going to look like. So for every 6 votes that Evelyn got, her opponent got 5. Because remember, the opponent lost and Evelyn won. So remember, this is Evelyn's vote and this is opponent's vote. We'll follow the exact same order. We are going to put Evelyn in the numerator. These are the number of votes, the actual number of votes that she got. What are the actual number of votes that the opponent got? Make sure they're consistent. For every 5 votes, that's the opponent in the denominator, that the opponent got, Evelyn got 6 votes. And be consistent. In the denominator is the opponent's vote. We don't know what that is. And in the numerator is Evelyn. Now we cross multiply. 6x equals 7230 times 5. So 6x over 6 is equal to 7230 times 5 over 6. we cancel common factors. X is equal to 7230 times 5 divided by 6, and let's see if we can cancel common factors. Let's try to figure out the answer first using a calculator. So 7230 times 5 divided by 6, and it's equal to 6025 volts. So let's put this down somewhere. Now remember, technically we've solved the equation. If you're allowed to use a calculator in your next class, you're basically done. You're going to enter this into your calculator and you get your answer. But in this class, we're going to try to do this by hand. So we have 6 in the denominator. So let's see, 723 times 10 times 5 divided by 3 times 2. So I know 2 goes into 10. And remember that every step is an equation. Don't skip anything. Just write down both the sides of the equation. Go vertically down. That's the best way to be organized. And then here we have, let's see if 3 goes into this number. How do we know that 3 goes into the number? 7 plus 2 plus 3. 7 plus 2 plus 3. 7 plus 3 is 10 plus 2 is 12. So 3 divides 12. So we know that 3 divides 723. Just recall. So we know for sure that 3 divides 723. And why do we care? Because we have a 3 in the denominator and we are hoping it'll cancel with the 3 in the numerator. 3 times 2 is 6. Subtract, you get a 1. Bring the 2 down. 3 times 4 is 12. Subtract, bring the 3 down. Subtract, we get a 0. So bring the 3 down. 3 times 1 is 3. And we are done. So we have 723 is 3 times 241. Remember, that's a 1. And 10 is 5 times 2. And then we have another 5 divided by 3 times 2. So that's good because the 2's cancel and the 3's cancel. And our final answer is just multiplying these numbers together. 241 times 5 is 25. 5 1s are 5, 5 4s are 20. Carry the 2, 5 2s are 10, 11, 12. 2 1s are 2, 4 2s are 8, 2 2s are 4. And let's add. So we have 5, 2, 8 plus 2 is 10, 4, 5, 6, 6,025. Now let's think about what this 6,025 really is. So the question says that for every 6 votes that Evelyn got, the opponent got 5. And using the same ratio, can we figure out how many votes the opponent got, the actual number of votes that the opponent got, if we are given that Evelyn's total was 7,230 votes? So we set up a proportion, and now we have the answer to that question. So if the total that Evelyn got was 7,230 votes, then we can be sure that the actual number of votes of the opponent is 6,025 votes.